Alright, so what we're going to learn here today is we're going to put all the skills together we learned yesterday into a really long problem. And it's one of many types of stoichiometry. This is the one that chemistry students learn first. It's called mass-to-mass stoichiometry. So we're going to start with the mass of one chemical and find the mass of another chemical. Stoichiometry, all stoichiometry requires a balanced chemical equation, because the only way to get from one chemical to another is by knowing the ratio of moles in the equation. Okay? So there's a lot of steps to this, but the main steps are you get from the mass of the first chemical to moles. The moles of the first chemical to moles of the second chemical, and finally moles of the second chemical to the mass of the second chemical. Okay? So it's basically a three-step process with a lot of other stuff that gives you the information you need for those three steps. Yes? Sure, you can sharpen your pencil. Yeah. All right. So here's our example problem. If 3 grams of potassium hydroxide and the formula for that is KOH, I'm going to be nice and give it to you, is dissolved in water, what's the physical state if it's dissolved in water? Aqueous. And then it's mixed with an excess. That means we have more than enough, more than we need, an excess of aqueous aluminum chloride. I'm being nice and giving you that formula too. We just kind of did that one. Let's see. What mass of aluminum hydroxide Man, it must be awfully cold in Hades today because I'm being really nice, huh? Oh, I'm just playing around. You know I'm nice. Come on. What mass of aluminum hydroxide will be produced? Okay. You know, if you're nice, I'm nice. You just don't think I'm nice when you act up all the time. Come on. And we'll take a little poll. We'll find. All right, this person's nice, and ask them, and they all think I'm nice. Yeah. Okay, look now. I think you need to just kind of calm down. Okay. I'm trying to be lighthearted here. Come on. All right, y'all got this written down? All right. Rose, find the off switch, please. All right. Well, let's start building up. If you've already written this down, go ahead and start trying to figure out your balanced equation. Put together all your chemical species here. I'll go through it with you. Has everybody written it down now? Okay. I'll wait till everybody's written it down to start, but I'll let you get a head start. Yeah, we're going to get a balanced equation. So the first thing you want to do is just write down your chemical species, predict the type of equation you're going to have, what classification it is, and predict your products. One of the products is already given to you in the prompt. in the question. You ready? Okay. So the first thing we have is potassium hydroxide, and it says it's dissolved in water and mixed with an excess of aqueous aluminum chloride. Well, that's what you're doing with your starting stuff. Those are your reactants, okay? So we've got potassium hydroxide, and we have aluminum chloride.
We don't need to put that 3.0 in.
What now?
We don't need to put
No, you don't put grams in a balanced equation. Grams don't. Only thing that goes in the balanced equation is coefficients. Okay, well, physical states. All right. Well, let's see. What physical state is the potassium hydroxide? Aqueous. And what physical state is the aluminum chloride? Aqueous. It actually says that in the problem, or in the prompt. Okay, so one of our products, it already tells us that. What mass of aluminum hydroxide to be produced? Well, that's a product then. So we know we're going to have aluminum hydroxide. Okay. It doesn't tell you what physical state it is, so we'll have to figure that out. So what classification of chemical reaction is this going to be? Double replacement. So the front part of this has got to go with the back part of that. We already have the front part of this going to the back part of this. There's the aluminum, and there's the hydroxide. We've got to get the front part of this one going with the back part of that one, so that's K and Cl. We need to balance K and Cl. Let's see. I'm going to do it in a little bitty writing up here just to kind of keep us on track. So potassium, if you look it up on the periodic table with oxidation numbers, is 1 plus. Chlorine is 1 negative. So a balanced formula is KCl, just one of each. Okay. We need to know its physical state. For that, we need our solubility rules. It's aqueous. There's 2 rules that pertain to that. The very first one says all group 1 salts are soluble all the time. The second one says chlorides are soluble with exceptions, and potassium is not an exception. So this is aqueous. And what about this aluminum hydroxide? Hydroxides, it says down here under the insoluble section, hydroxides are generally insoluble. Now there's exceptions for group 1 metals or group 1 atoms, group 1 elements, strontium and barium. Well, that's not aluminum. That doesn't include aluminum, any of those. So that's going to be a solid. This is one of the hydroxides that's solid. Okay. Group 1 elements. That's everything from hydrogen all the way down. Okay. Group 1. Remember, Unit 2 we did section of the periodic table, and Group 1 is the first column, and Group 2 is the second column. Okay. So now we're ready to balance the overall equation. We've got all our formulas balanced. Okay, we're ready to balance the equation. So we'll make a list of all our elements. We've got potassium, oxygen, hydrogen, aluminum, and chlorine. So we need an atom inventory grid, or sort of a mini little spreadsheet here. I don't call it a table because I'm really picky about what a formal table really is. So potassium is, so let's see, we have 1 of those, and we have 1 oxygen, and we have 1 hydrogen. We've got 1 aluminum and 3 chlorines. And over on the right side, we're going to put those numbers over here in this column. We have 1 potassium. We've got how many oxygens? 3 oxygens, 3 hydrogens, 1 aluminum, 1 chlorine. Good. All right. So we want to try to get all the numbers of atoms to be exactly the same on both sides. And for that, we have to have coefficients. The formulas are balanced, and once the formulas are balanced, you can't touch those. Leave the formulas alone once they're balanced. We only use coefficients to balance equations. So we always save oxygen for last and hydrogen next to last. So that leaves us with chlorine. To get 3 chlorines on the right, we have 3 on the left. When you get 3 on the right, we need to put a coefficient in front of the species that contains chlorine, a coefficient of 3. That's going to change the number of potassiums and chlorines. With that 3 coefficient, that multiplies everything in the formula by 3. So we have 3 potassiums and 3 chlorines. And now we need to go back over here and get the number of potassiums right on the left side. So I'll put a coefficient there of 3, right? And that's going to change the number of potassiums over here and the number of oxygens and hydrogens. That 3 in front of those, you have 1 of each in the formula, but 3 times the formula, so that's 3 of each of these. And it's balanced. Okay? All right, so that's what we need to do just to be able to be kind of ready to go. All right. To go from grams of this, which is mass, grams measures mass, to the mass of this, I've got to get to moleville first. Okay, earlier I said I've got to get from grams to moles, and I just call that whole thing of going through moles, moleville. Okay? How do you convert grams of a chemical into moles of a chemical? That big number, okay? What do you call that whole big number? Huh? We just did it for homework. Huh? Molar mass. You got to have the molar mass of this. You got to calculate the molar mass of potassium. Since I have grams of potassium hydroxide, to get the moles of potassium hydroxide, I've got to have the molar mass. Mass to moles, molar mass. Got that? No. We're only looking for the molar mass of the formula itself. We don't worry about that 3 in front. That 3 in front will be taken care of later. And if I can remember, I'll try to point that out to you where we're going to do that again, okay? All right, so the number of potassiums we have in the formula. Now, but that's a really good question because that happens a lot on tests. Students will confuse that. They will look at this coefficient 3 and think, I need 3 potassiums. Not so. You look at the number of potassiums in the formula. Don't include the coefficient when you're figuring out molar mass. Only the number of atoms in the formula. Does that make sense? Yeah. All right. So we're going to have 1 potassium, and potassium's atomic mass is 39.0983, and oxygen's atomic mass is 15.9994, and hydrogen's atomic mass is 1.00794, and I have 1 of each of these. So we're going to add up 39.0983 and 15.9994 and 1.00794. Once again, notice I've been very careful to keep all the digits lined up in a nice, neat columns. It allows me to easily see I have an empty slot here and here. Okay? So when I add these together, 56.10564, I can see that this 4 results from adding numbers we don't even know what they are. Empty slots, I call them, okay? So that's an insignificant digit. We're going to round it off. So we're going to take and round off this number. And we have now 56.1056. And the definition I gave you yesterday was molar mass has to have, well, this is not part of the definition. This is part of determining, telling you what I expect in this class. That you're going to write this number with the units of grams, and you're going to write it with the species, KOH, and you're going to set it up with an equality statement. And this mass of this species is equal to 1 mole of that species. Okay, so there's your equality statement you need for a conversion unit. Well, the question is, we know you can make 2 conversion units from the homework. You know you can do 2 conversion units from this. Which one do we need? Here's how we figure out which one we need. We're going to start with the starting amount in the problem. And starting amounts always go over 1. Starting amounts always go over just the number 1. Not 1 mole, not 1 gram, not 1 liter, not 1 milliliter, not 1 Fernando. Just the number 1. Okay? 3.00 grams of KOH. Okay? Over just the number 1. Okay? Got that?